Now that you're familiar with both mesh current method and node voltage method, some obvious questions are when is it better to use mesh current method and when is it better to use node voltage method? And we're going to look at a few things to consider which can maybe help you choose, but ultimately it's going to depend on your preference. So let's look at a few important considerations. The first is how many equations are going to be required for a given circuit using either of the two methods. So if we look at our mesh current method, we know that we have M meshes. We're going to need M equations, where again, let me just be explicit. So M is our number of meshes. For our node voltage method, we know we're going to need N sub E minus 1 equations, where again, to be explicit, N sub E is the number of essential nodes. So maybe in a particular circuit, we're going to need significantly less equations with our node voltage method, so that makes that a more attractive option. We should also consider, though, just number of equations alone is not necessarily a good metric because maybe we have two very complicated equations versus three simpler equations. So something else to consider. Again, coming back to this idea of preference though, maybe if you're more comfortable with mesh current, then dealing with an extra equation or two is worth it as opposed to having to deal with the method that you're not as comfortable with. The second thing to ask ourselves is, what are we ultimately trying to find? So remember, ultimately we're going to be looking for some power, some voltage, some current in the circuit. And so oftentimes these can be easier to find using node voltages or mesh currents. So let's just say this might be easier to find with our node voltages or our mesh currents. And so as sort of an easy example to visualize that, let's say we wanted to find some voltage in a circuit. Now that might not correspond to a node voltage, but let's say it does in this simple case. So if we go through our node voltage method, we don't have to do that last step at the end where we relate our node voltages to what we're trying to find. Whereas if we had used mesh current method, we need to take one additional step to then relate those mesh current methods, or use those mesh current methods rather, to find our voltage of interest in this hypothetical example. So important thing to keep in mind as well. A third consideration is location of sources. So let's consider first our mesh current method. So for mesh current method, if we have a current source on the perimeter, so current source on perimeter, as we've seen in a previous example, that makes that quite easy because we can just say this mesh current in that perimeter is equal to the value of that current source. So we get sort of a free equation there. However, if we have a shared current source, we know that we're going to need to use a super mesh. So shared current source means we're going to need a super mesh, and that's not necessarily a bad thing, but again, maybe you're not as comfortable with mesh current, in particular super mesh, so maybe if you see that in a circuit configuration, you want to avoid that if possible. Let's also consider some things related to our node voltage method. So if we have a voltage source that's between our reference node and some other essential node, so voltage source between an essential node and our reference node, that is also an easy case. So that's sort of analogous to this case here of our current source on the perimeter, because in this case we can just say our node voltage at that essential node is equal to the value of the voltage source. And as I've talked about in some of our node voltage videos, we can sort of choose where we define our reference node in some cases to accommodate a voltage source directly between two essential nodes. However, there are some cases where we could have a voltage source between two essential nodes. So voltage source, and this voltage source has to be alone, so no resistors, so alone between two essential nodes, neither of which are the reference. And so in that case, we have to use our supernode method. And so just like with our super mesh, that doesn't necessarily mean it's harder or more difficult inherently, but maybe you're not as comfortable with the supernode method. So all of these items are important things to consider. Something else to keep in mind, of course, is in class for an exam or for a homework problem, I might be telling you you need to use a certain method. But this is more beyond this class as you're working problems. This can be a useful guide in terms of when mesh current method might be easier, when node voltage might be easier. But again, ultimately, it's going to come down to your preference. One other important point to mention that we've mentioned once or twice before in previous video is that we have two types of circuits. So remember, we have our planar circuits and our non-planar circuits. And so for our planar circuits, we can use both mesh current method and node voltage method. But for our non-planar circuits, we can only use node voltage method. So again, one more item to consider.